Koska niiden piti tulla?
Kyllähän ne pitäisi aika lailla nyt ruveta tulemaan.
Mahtava juttu.
Joo.
Hey, customer is coming. Please come here. Customer is coming. Welcome to Prima Power Finland. We are here for you and everything is ready. Great to see you all, and welcome to Door and Frame Manufacturing Open House. Everything here is ready, factory is running, and showroom is prepared for demonstrations. A couple practical topics first. The webinar, of course, you can write your questions, and we will answer them in the end of this event. So today we are producing doors and frames. Of course, this event and manufacturing process is valid for other big panels as well. But anyway, now we are dedicated this event for door and frame manufacturing. So Antti, what we are going to do today?
Yes, Antti. Today we are going to follow up step by step the so-called normal door production process. And we are going to see how we are going to do it with the Prima Power machines. And we are going to face the same issues that are all guests today globally, the hundreds of you over there, are facing day to day. So we are showing how these things can be done with Prima Power machines.
Mm-hmm. I can see here already some components and semi-finished parts and a couple nice different design doors. And so are these the components and the doors we are producing today?
Yeah, by these products we are showing how our machines are capable of running these as fast as possible and how these elements can also fit to your production.
Wow, it's going to be very interesting hour and a half. So stay tuned. So we will show all the tricks what we can do here. First, now when we start going through the agenda, first we go through a little bit about the door manufacturing mega trends. Why the doors and frames are interesting, of course, for many producers, and also that the commonalities, what all doors and on the other hand, all the frames, they are in the manufacturing point of view. So I will go through these things in a short PowerPoint presentation, so we can start it here. Okay, let's go through some door and frame manufacturing and production general requirements. Door industry in general, of course, it's following some worldwide mega trends like any other production, and for door demand is growing due to the fact that the Earth population, of course, is growing, as we can see in the chart below. This, of course, affects immediately then the demand for housing and apartments, and of course that the people are moving from countryside to big cities. So that's generating again more need and demand for the doors and frames. Also that all other premises, external premises like schools and stores and etc. All of them they having a lot of doors. Possible segment, of course, is growing also because transferring from traditional wooden doors to sheet metal doors. And this is possible due to a couple of facts, of course, that the design and the manufacturing possibilities, but also that the process itself is becoming so much efficient that it's less energy consumption. There's, of course, due to this is less pollution, and also that the working stages are less and less because in production and manufacturing there is not that many manual work anymore required, like welding or washing or grinding and painting and so on. Demand change, of course, then generates some more improvements and requirements like designing. So trends changing more rapidly. So year by year, the architects and designers, they are designing the new doors with a new outfit, new colors and so on. So material technology giving a lot of possibilities really to get new kind of textures, skins and colors for the materials. Also currently the modern manufacturing technology, the producing those is very easy and simple. So like roll forming and also the all kind of markings make it possible to make the design to be really unique, and this of course helps a lot. There is a lot of commonalities in this segment, like the doors. They are big panels, of course, produced in thin materials and mainly made pre-painted or coated materials. The frames in such is of course then made a bit thicker materials. Many times they are not pre-painted because they will be painted afterwards, and they are narrow profiles. Then of course different types of the doors like safety or fire doors, they have different types of requirements, like safety doors more like more advanced locking systems and better hinge systems and so on. And of course all this can be automized by using the parametric programming, and also this variation of requirements of course is then easy to produce and manufacture. This kind of trend and design changes and unique doors, of course, it needs the way how from the concept to the reality can become in a minute. The modern tools like 3D designing softwares and visualization of the models in virtual 3D reality, of course, can be checked at how they look. But also the real door manufacturing process is very easy and simple now, these days, because all our softwares are supporting these 3D models, and single prototyping and a demonstration door can be produced in the same way like normal production doors. So it's very easy and really from the concept to reality in very few minutes. Then the production requirements in general, of course, are changing throughout the years as well. And today's demand, of course, is that there is a small quantities per order. Even though there is a big order for some apartment building, for example, but each and every door and frame set can be slightly different, left-handed, right-handed, different colors, etc. Also, the fact that the delivery times has to be short, because no one wants to keep, let's say, the money in stock, so delivery time should be fast. So this, of course, creates some demand and requirements for the production capacity. Then material saving, of course, the direct cost saving on the materials, and then the kit production, so that we could make these kits easy for assembly and delivery. They have been not, let's say, possible at the same time. That's on the past. But nowadays, currently the automatic and automated production lines and the good softwares supporting the order management makes it possible also to get the best out from the material saving and kit production benefits. And of course, in the good software, let's say, eliminates the bottlenecks on programming and the order management. So the office work is not a bottleneck anymore. And then for the assembly requirements, all small details and additional working stages like forming, tapping and marking, of course, makes much more easier and efficient and faster the following stages. Production solutions for the doors, of course, should be very fluent, sleek and continuous flow. And we can offer this type of line, as we can see in a few minutes, the production line, that the material delivery has to be fast, of course, and there has to be each and every sheet different type of the material, colors and size, so that we can match the small patches. Then the line has to be continuous, so that the immediate parts, when they are cut, so that we can move them to automatic bending without any waiting times. So in this way, of course, then the production can be as efficient as possible. Then for the frames production, of course, depending on the volumes and the quantities, the frame production then can be done on the same machineries, but of course then additionally we can continue the line by robotized press brake cell. So for example, the narrow profiles, we can do the last bending by using the robotized press brake cell. Or of course we can have the separate line for the narrow profile frames, in the sense that we have a dedicated profile bending automation with industrial robot in front, which takes care of the loading and unloading of the part. So, like in this example or presentation was mentioned, the design for the doors and frames very often. So the designers and architects are playing around with the 3D models and making them as a 3D model, and then quickly to production for prototyping. So now let's start going through this process from the beginning. So we can go through the step by step all the phases, but of course, and obviously we start now by using the example from the 3D programming. And our colleague Fred Cook from United States, he is showing us how this goes in practical life. So let's take a look. Hi, Fred.
Hi, Antti. How are you?
I'm fine, thanks.
Great. Well, let's get going here with NC Express, and we're going to show you how to import an assembly and process an assembly of a door frame. So here we are in NC Express. We'll open up the assembly file, which is straight from SolidWorks or Inventor, whatever you want to use. It brings in the full assembly, and including hardware, screws, door handles, hinges, etc. So we can see if we select any of our parts, we can pick the door skin, the door frame, and already we're mapping materials to our database. So we can go here to the assembly process. And when we push play on assembly processing, It runs through the parts and checks if we've already processed these parts in the past. If not, they're considered new. If they are, then we check the modified date and check the revision. So these parts are unfolding and are saving and are tooling up. And we get a successful process here. So all of the parts have been run. It's just asking for a new name for the assembly, so we'll give it that. And from here, we'll go to File and look at the part and start nesting. So we'll go to our orders database, select orders. We can select all of these parts that the order has been created for from us now from this assembly. So here we can hit nest. There are two different material types, so there's two nests going to be made. And just automatically process these parts. So the nesting is done. We can select all of the nests and process them, and this will do the optimization, as well as making the NC code for the programs. So once that's done, we can take a look at one of these nests, and let's go to the first part and take a look at the door. So we go to the door and open the part. Once this part is open, we can then go to our bending element in NC Express, and it will open up this part within the bending interface. So here's the part. The machine is already selected. And we'll just tell it which way we want the part to come into the machine, what angle 0 would be. So from here, we can select the bender process and do automatic programming, short sides first. So what this is doing is it's automatically generating the program now based on doing the short side of the panel first and then the long sides. So we have a single tool set up in the machine. So it's churning away. There's ups and down bends in this part. So program is ready. So we can zoom in, see the part has nice tight corners. Here we can select our bender process and push play and see the simulation of the part being bent in the bending software. So one short side, second short side, and a long side, and a long side. And the unloading is taken care of as well. And that's programming. So back to you, Antti.
So, thanks, Fred. That was nice to see how easy it's to program the complete production line with all the punching and planking and also the bending included. So very nice. Soon we will see the real production of these lines, correct?
Mm-hmm. Yeah.
In the production line. But before we start to run real production with these doors, we will play you a short clip to show and demonstrate the main modules of the production line. So it's easier for you to then to understand and follow what's going to happen. So let's check this quick video now. These were the main modules of the PSPP line. And now we can see that the production is already going and the complete line and production flow is there. So Antti, what's going on now in the line?
Yeah, now the PSPP line is already running and we are running the so-called high volume door. So we are showing you how fast we can make the door panels and how fast we can make the door frames.
Now we switch to another camera where we can see the end of the line, the bending phase. Now we are looking inside the panel bender where we can see how fast the bending process actually goes. As the frame is finished, it is being unloaded by conveyors and simultaneously the loading device is already bringing the next part to the bending. We are running a kit production in this demo, where first we make 3 frame parts of one door and By following those, we produce the door leaves, inner and outer skin. In this view, you can see on the left the turning device, which is turning the door leaves before bending. As we have pre-coated material, we want to keep the painted side on upwards in punching phase, but for bending we need to have the painted surface downwards. With this turning device we can perform the turning on hidden time while previous part is being bended. Now we are moving along the BSPB line from bending to punching and shearing phase. You can see how frame and door leaf parts are lined up for bending phase. Then we skip to the beginning of our production line, to inside the material storage, where we can see how the loading has started. Our fast loading device gripper is taking the sheet directly from the material stack, and you can see that we have different colored material for door leaves and thicker material for frames. Here on the punching machine the loading device gripper is waiting with door leaf sheet on the gripper as we bring already the next door frame sheet to loading table. Now the sheet is loaded to the machine and we start the punching of door leaf. The coordinate table is moving the sheet along the machine tables and we are rotating the tools with the turret and punching the corners of door leaves. As the door leaf program is almost ready, we start already the preloading of the next sheet by taking the sheet from the table to loading device gripper. On the punching machine you can see that we have started the shearing of the part, and that way we can release the blank to the line for bending. And now we switch back to the bending. Here on the punching side we have punched the door frames and we are releasing the frame parts by shearing to the line. You can see that even though the door leaf and door frame materials are different thicknesses, it doesn't require any actions from the operator. The punching, shearing and bending can automatically adjust themselves for different parts. And on the panel bender, the parts are finished fluently and operator just needs to pick up the ready parts for the following production phase on a factory.
Wow, it's interesting to see how nice and smooth the production flow is going, and there's no any bottlenecks in this line. So it's really like a direct continuous production.
Yeah, with this door production we can balance perfectly the punching machine and the bending machine.
Yes, all big panels of course, and this type of line is really easy to make this balance and flow to be perfect. Yes. But anyway, we were producing one of these doors, and the doors we were producing and the frames, of course, was like this one. So Antti, can you explain and tell a little bit more about what is this door?
Yeah, as we mentioned, this is the high volume door. So we only have the necessities in this one. We have holes for the lock mechanism, we have holes for the handle, we have holes for the hinges, and we have a couple of holes here to fix together the inner and outer skin by rivet nuts. So that's all that we have in this door, and that way we can achieve the biggest capacity with our machines, and we can get a lot of these done in 1 hour.
Looks good, looks perfect. And of course we were producing the frames as well. So of course the frames has to match the door and also the wall next to to it.
Yeah, of course.
So this is of course parameterized and order-based programming.
Yeah. Antti, all the time we have been talking about that this is fast and high volume door, but can you say how fast released? What is the actual capacity with this kind of a line for these doors?
Yes, yes. Of course, yes. This is really the question now. The high volume productions, how long it takes to produce one door or frame or kit, how long it takes to accomplish one order, what a construction company, for example, gives to us, or what is the annual volume and capacity, so we can calculate the payback time and see if the investment is then okay to make. So I will make the one short presentation now and a couple of examples to give you the idea that what is the production volume and capacity of this type of line. So as we see, the production line is very efficient and very powerful in production. The question is that what is the production capacity of this type of line? I have been prepared a couple examples here to demonstrate and try to get some idea or give some idea that what is the capacity of this type of line. Door production, of course, it's based some kind of orders. It could be like a bulk doors, which is sold throughout the hardware stores in the countries. But of course, many times the bigger quantities are produced order based from construction companies, for example, apartment buildings or cruising ship builders, etc., which then requires the bigger quantities. Of course, there is not so many similar doors because there is a variation of the sizes, dimensions, colors, etc. So order parametric and automatic production is then required. Here is the capacity simple calculations. I made the sample here. The building you can see behind me, this kind of apartment building, and the construction company placed an order for all the doors for this building. So that there is 81 safety doors and 176 fire doors. And there is of course a lot of variation of the doors, right-handed, left-handed. There's a different wall thicknesses for the frames. There's a different colors. There's a different number of ceilings on the frames, etc. But anyhow. Total 257 door and frame kits, meaning that 1,285 individual parts to be produced to complete this order. Table below here you can see the times per part, how much it takes and so on. But anyway, the important topic here is that the complete order for this one complete building can be accomplished less than 13 hours. So the whole order can be produced in less than 13 hours. Okay, so it's very powerful and sounds very short time because just in a 1 day production time we can produce all the doors. So then if we take a look and another way around this topic, that what is then the annual capacity of this type of line? So if, again, we keep the same example order, we can, this type of line and this type of design, of course, you can understand that the design affects a lot for the production times, but this type of time and production orders and design, we could accomplish 646 orders annually. There is a fact, of course, that we run 24 hours per day, 360 days per year, and a 95% efficiency rate. But 646 orders annually, meaning then, of course, quite many individual components. But then, of course, turning this a little bit to money, just to give some example and idea is that if we can assume that we could charge 50 euro from the construction company per one kit of door, including the door and frame. 50 euro, okay? one 13 hours run, we could invoice a bit less than 13,000 euro. And the capacity in this example shows that we could perform 646 orders per year. Means that we could get the turnover sales for this production line 8.3 million. Okay, then of course we can make interesting calculation for the payback times for this type of lines. So this is of course now giving the information the companies who are not using our technology, the producing the doors and frames. So I am and we our sales team and the back office team, we are more than happy to complete the time studies, production simulation and analysis for your doors and the frames, so that we can see how big and how much we can improve the capacity of your manufacturing. The companies who already have our technology involved, there's one example. 7-year-old line. We run, just an example, 20 piece of safety doors. So production time for these doors was 1 hour 38 minutes. And we run the same doors with the same tools and same materials with today's door optimized production line. And the production time was only 39 minutes. So you can see huge improvement. So this is possible, we can do. And of course, again, we are happy to make some time studies, production analysis and simulation to show that how big improvements we can offer to you. Here is the example is 7 years time difference, which is, by the way, is our standard leasing time. So we can always guarantee that in a leasing time period, 7 years, we can minimum 30% we can improve the productivity. But for example, in this case, when we have improving and dedicating some ideas and forces and optimizing the door manufacturing, we can offer you so much more. So this gives some idea, and let's take a look later on how and what more we can offer in the production lines. While the capacity is high on this type of line for this type of doors, but of course you always have a different kind of design for the frame profile and also the doors. But modern technology and machines gives, of course, the possibilities to add features for the doors, which are improving the quality, which are making the design easier, and also that which then make the assembly easier and faster. So there is a lot of things in the punching and planking machine, but also the bending, which makes this possible. And our product manager, Lauri Piirto, he will come here and gives us some ideas and explain more about those details. So, hey, Lauri, Marko, can you please give us some information about those?
Yes. So, as you mentioned, with our technology, we can add features and design details for door manufacturing. So we can combine work stages into one setup, and this gives cost savings and brings flexibility for single door production, for example.
Very nice.
Here we see some offset areas to bring more stiffness for handle or unique design, and those two bring stiffness, and therefore we can have we can use thinner materials and have cost savings. For assembly, we can have extrusions and tappings for screw assembly, for example.
Mm-hmm. And I can see that there is like a Prima logo made
yes.
here. So this is this like a stamped, or how it's?
No. It's we use punching toolings with servo axis to create such features.
So basically, every door can have a different design.
Exactly.
Very interesting.
And I would like to tell you more about our technologies.
Okay, please, Marko.
Punch and shear technology. It is the solution for door design and manufacturing. Fast and reliable cycle times, high sheet utilization because there's no skeleton. High parts quality thanks to right angle shear plates. Easy to automate. You will learn more about this during today. And lowest cost per part. I have some comparison to explain more. And what this green means, really. For door manufacturing, we have typically these big corner openings. So we need tooling, we need big index toolings to create these openings fast. Also, we need formings, for example, to make extrusions for tappings. And of course, we make the tappings. Different kinds of other details, like these kind of cups, if needed. With wheeling technology, we can create mirrors to door leaves, or just simply offsets for other unique design. Like, for instance, today we make the Prima Power logo using offset wheelings. With rib wheels, we can make more stiffness, also like offset wheel. We create stiffness to the door leaves, and therefore we could even reduce material thickness and get cost savings on that way. Snap locks, knockouts, other similar special tools which comes from punching tools. With right angle shear, we simply release the part using the blades, single hit and part is out. And today we make this kind of design door as a production demonstration. We use offset wheelings inside and outside, let's say. And these design details can be unique. Single piece, and then the next one can be something totally different. Punching and indexable forming system. It is fully servo electric. Means no oil, no heat on the process. Servo electric means also high accuracy, high speed and high tonnage, and low energy consumption. Average power consumption only 5 kilowatts per hour. With the forming, we reach 16 millimeter forming height, including material thickness. So relatively high design details on door leaves. Customized active turret. Active turret means all the tools available with very fast tool change. Customization means that we can make a turret layout according to your needs, according to your tool list. High tool capacity means no setups. Easy automatic programming, auto tooling. All these together means high productivity without any setups for continuous production. The shear simply means fast part release and high cutting edge quality. It is also servo electric. Once again, no oil, no heat on the process. Automatic clearance settings for whole material range means no setups. Thanks to a servo electric, we have always optimized stroke length according to the need, according to the cutting length. And this gives us fast process. Big shearing plates, 1000 times 1500. Full stroke and part is out. This is maximum part what we can get out with single hit. The blades is progressive, just like scissors. Fast, simple, and reliable. Today we have laser marking on our production demonstration, but we also have inkjet or labeling device as an optional feature for marking applications. And now coming to these comparisons what I promised to give. This is comparison for electric consumption per year. 2 shifts means 16 hours per day. Working days per year. And then there is a power consumption and then the rate, what is the price for power. And we see relatively high difference when we come from traditional hydraulic machine to new modern servo electric machine. Relatively big savings per year, and this is really the green means. Another comparison. This is one example of a design door manufacturing. We have 4 different production methods here. Traditional hydraulic, punch and shear, our new servo electric punch and shear, traditional 2D laser, and servo electric punch. We see cycle times, and on the calculation we have some service costs and other costs we take into consideration. And based on this calculation, we see relatively big difference between production methods. Cost per part, and depending on if we use 1, 2 or 3 shifts per day, and the whole capacity per year, the difference is remarkable. So, punch and shear technology. It is the solution for door design and manufacturing. Fast and reliable, no skeleton, no oil, no heat on the process. High part quality, easy to automate, and very green means, low cost per part. Money on your pocket. Now let's go to bending side. First of all, we have material loading and rotation for pre-painted or pre-coated materials, quite typical for the doors, like today we see. We have automatic tool change and part rotation. Means we can do the bendings all 4 sizes. We can do bendings up and down, means positive and negative bends. Naturally, in the end, part unloading. And automatic offline programming is available fast and easy. Now a few highlights for door manufacturing especially. First of all, the bending process is fully servo electric. Once again, no heat on the process. Programmable grounding gives perfect quality for long parts. And there's no blade wearing effect. We don't need any compensation on the blades. For improved material database, we do with automatic profile, inspection and correction. So we get perfect quality right first time. Narrow profile tooling and pen cutting profiles. We can use that, for example, to bring stiffening to door frames. Easy air bends by the operator. For example, ceiling roofs.
Wow, it's really interesting to see how those, for example, those design elements are really appearing to those sheets. So thanks, Marko.
Thanks.
Now, of course, when we see all these design elements and also the features of the panel bender, now, of course, most of you, I think, wondering that how we can organize the order and ordering process. So, I mean, the programming, automatic programming, because of small series, batches, and a quick delivery time. That how we can make the programming, because many times this can be the bottleneck for these kind of things, and also then that how we can organize and follow the production. Okay, answer of course is the software. So we have the automatic software, and our system software manager Pasi Kiviluoto, he can explain a little bit more that how this magic happens to handling the orders and the production. So
yes, we have a full integrated software with ERP systems, and we get orders automatically from the ERP, and we generate back reporting from production from each work step separately, that you can follow your production from the office. And of course, programming goes automatically for blanking and bending work steps, so you doesn't need to programmer at all if you can run that way. And the most common way in door and frame manufacturing is using parametric parts, which, where you can tell which kind of features you have in the door or any parts what you are producing.
So basically, for example, the every door can be different width and height, and by using this parametric program.
Yes.
This is very good.
Yeah. And more detailed information, Fred saw some presentation and explain more about that. Fred, you can start.
Thank you, Pasi. So welcome to Tullus Office Premium. This screen we have the dashboard, and we can see all of the machines in our factory and the immediate status of those machines, whether they're online, offline, running, or if they're in failure mode. Maybe we've got an alarm that has stopped them for some reason, or if they're idle, waiting for work to come to them. Here we can go to the production order screen. We can see all of the open orders that are running through our system. So in this particular order, we can see basically a progress meter. We can see that 75 parts or sets of products need to be made, and so many have been punched and so many have been bent. And we can also control or see hardware or stamped parts or purchased parts that are needed for the assembly. And we can track that they're able to meet up with the product and get it through to final assembly and get it invoiced. So let's close that screen, and we'll go here to the programming screen. And in programming, we can see the parts that have yet to be nested. So these could be coming from your ERP, MRP system. We've got text files, XML files that's coming from there. And today we're going to manually drive the process just to show you how this operation is working, but we can do all of this fully automatically. This is all going to work in the background. So we'll take these 5 parts and we'll select them to move to an order. So with those selected, we have the opportunity to make 2 nests because there's 2 different types of materials. So typically we've got here 0.8 millimeter and 1.5 millimeter materials. So we'll do a nest for one and a nest for the other. And once those are nested up, we'll take a look at this part. This is a parametric part. So we'll open up parametric. So this is a door panel where we want to control the X dimension or the Y dimension of the door, because doors come in all sorts of widths and heights. And then we've also got Boolean operators as to whether a spy hole is present or a letterbox is present, and those are just true-false parameters. So you can have pretty much an unlimited amount of parametric scripting that can be done. And the scripting can include tooling, which can be done automatically, or we can actually hard code the tooling into the script so that those tools are always used. Here you can see for this part, we can see the parameters that are entered in. So this door will be 2190 millimeters by 850 millimeters. And the Boolean operators for the letterbox and the spy hole are turned on. We'll take those parts and we'll move them to the calendar. And what that'll do is it'll make the nest, and it'll tell us here we're getting a flag for so many doors and frames that we've got one sheet that has a low yield, 57%, and that's below our threshold. So we've checked to include it, so let's add it. And so we always get the opportunity to say yes or no to some of these nests, even if the yield isn't fantastic on one or two of them, but we still want to get the production through. So speaking of yield, we'll look at filler parts. So here, filler parts are already designated. We can select this order here for a drawer set. So let's make this, and we're going to have some gaps in some of the sheets here. So once we nest these parts, we're going to see where our yield lands. So we have one sheet with poor yield down the bottom, and the rest of the sheets are pretty good. They're over 70%, so 73, 81, 90%. And we can see, we hover over, we can see the shapes of these nests, and we can see where the gaps are. So we'll tell the software to include that sheet and make the parts, but we're going to add parts, and we're going to add filler parts. So we'll select, whatever parts we have in our bank of filler parts, and this software will automatically fill up the gaps. It doesn't make any extra sheets. It only makes the right amount of filler parts just to fill up the spaces. Now we've got super yield. So we're up 90, 85, 87, 89. Really great yield on the sheets, making parts that we know we want and know we can use. Now filler parts can also be items that can be made on any material or any material in any thickness. So you've always got options there. This is going to be a 3D part. So we'll take this 3D model. So in other words, there's no 2D DXFs or anything like that. We're able to process directly from your folder of 3D models. So this part comes in, and we can see it in NC Express, where we can take a good look at the part, unfold it, and tool it up. But we're going to allow Tullus Office to do all of that for us. So all of these orders now are running from solid models. So we've got some different materials. We've got pre-painted materials, different thicknesses, and we're going to go ahead and nest those and move them to the calendar. So the calendar is your overview of your shift structure of your floor. You can see it's grayed out there. We can see what our working hours of the day are. We do have an order in red here, and so that order is late, but we can click and drag and bring that order into a gap that we can see here on Thursday afternoon. So once we drag that over and drop it into the schedule, it's no longer red. It's now we're on time, or we're going to meet our requirements. And we can double click and open any of these in a very visual view and get some information. What are the nests? How much time are we expecting on these nests? What are the general yields? And you have a really good supervisor's overview here of what your plant will be doing for each of these machines. The next step here is scheduling, or grouping your schedules. So typically we want to make the parts how we want them to come out. In other words, to build kits that are billable, that we can get weldments through welding and parts through painting. But if we're running maybe a split production shift in our factory, we can group some parts by material type. So here we've selected to filter by materials. So all of the mustard colored parts there were one material, while the teal parts were of another material, and we can shift those around and kind of group them. This can be done automatically as well. It is possible to group by turret setup, which would be tools, but these days we can get so many tools in the turret, it's really not necessary. We're virtually able to get all of your setup into the turret in one shot when we do a proper study. That is Tullus Office Premium. Thanks for joining us, and back to Seinäjoki.
Thanks, Fred. So that was really nice to see how this complete assembly and order and programming process went through. And I think that also, of course, the reporting back to ERPs can be done by using this.
Yes, we are collecting a lot of information from the production.
Yeah, there was in between while you are here, Pasi, now that there was one question coming already from the audience, that what kind of ERP systems can we connect to all kind of ERP systems what the customer has?
Yes, there is no any limit with the ERP system. We have experience with homemade system, but also extra large system where we have connected our software, and we always supporting customer and giving information to them how to do it.
Mm-hmm. And we have done this more than 10 years already, this connection, so it's very, very good. So thanks, Pasi.
Thank you.
And now when all the orders are processed, and And these programs are now transferred to the production line, and everything is ready in the production. Then our product managers, Marko and Lauri, will come here, and they will explain now that what is going on there in the line when we are producing these design doors with all these features and functions. So welcome, and please go ahead.
Thanks, Antti. Thank you, Antti. So, Marko, you explained earlier that we can do all of these nice features, but can we do this with fully automatically at our production line?
Yes, we can do this with our, thanks to our servo technique, what we use. We can do all this with the punching center. But when we add the shearing to the process, we get high capacity and high quality.
Sounds really good.
Yes. And how about the material handling then?
We have example a seat-by-seat loading solution in this production line, what you saw. But we have production line running, so let's go to look at that.
Yeah, let's move to production cameras. Okay, and the production is already running. Now we see the bending process. Actually, we do the door frame parts, but what we really do in behind, instead of looking at the different parts coming one per another.
We are really producing single kit production. So we have the order. There is two different types of doors, gray door and the white door, and also, of course, frames for that. And we are having the single kit production and really fast material changes, what we can show you later on.
Yeah, so actually now we have a long frame part, and right after that we are already preparing a gray colored door, which was turned.
Yeah.
Yes.
And actually we can see here our 3 buffering units. Like we can have one part already at the gripper as a buffer, and one part at the turning device, and one part at the centering table. So we can have 3 buffering positions at the production.
Okay, and also here we see that we can even bring it directly to the bending process.
Yeah, from shearing process we have direct connection to the bending, and we can buffer parts also to the conveyor.
Now we are inside the storage. Can you tell a little bit what happens?
Yes, this is our sheet-by-sheet loading solution, fast loading device. So it takes the material directly from the storage shelf and it loads proactively. So we can see here the batching unit is finishing the parts. Our loading device have already next, actually it's
there's white sheet on the gripper.
Yeah, and the gray sheet is already at the loading centering table. So we can see here there is proactive loading for both from the storage and also from the loading unit. So we can have immediately the material available. Really fast material changes.
Okay, and now we are on the punching. We see the punching process. We open the corners, which is typical for door leaves.
What type of tools we are using for that?
We have big indexable tools to create the corner openings fast. And also now we see other details punched first, and then we use rib wheels to create stiffness for this door leaf.
We are creating the stiffness with the grip wheel, but can we do some other nice things with that?
Yes, actually now after grip wheel we start to make design details on the door leaves using offside wheeling in this case. We can make these kind of mirrorings for door leaves, which is quite typical, but today we use Prima Power logo, which looks quite fancy, in my opinion.
Yeah, it looks really good. Can we do this plus and minus?
Yes, actually we saw where the grip is coming. There we have
the door handle.
The door handle, yes. There it is the inside forming, and the logo is outside forming. Oh. So both sides is possible.
much capabilities there and possibilities.
Once again, another material change.
Yeah, a material change again. Single kit production, fast material change, and now we can see we are loading the white door leaf already to the production.
Okay.
So we can produce immediately the white door and after that the grey door or vice versa, and also the frames can cut there.
And now the white door is on its way to the bending process.
Marco, I saw that the part came really fastly from the shearing process. What is the secret in our shearing? That's how we can cut those parts so fast?
Yes, we have the long shearing blades, 1000 times 1500 millimeters, and this brings us a very fast and reliable part release.
Really good. And now we can see the buffering. Another part is unloading from the bender, and another part is at the gripper already ready for loading. Can you tell a little bit, Marco, about the bending?
Yes, here we see the part was centered, and at the same time we made automatic tool change. And as we see, we can make positive and negative bendings easily, and we can bend all four sizes on the parts.
Now we are marking. Marco, can you tell what is the marking technology what we are using now?
Yes, we use laser marking today in this the production demonstration. We make some traceability details to the frames. And this is quite typical for the marking applications, because those help the production follow up really how the material is going and so order handling.
So we can follow up the production, but can we make like a little bit more information there? Can we use like a QR code or data matrix?
Yes, we can use those. Those are possible to do with the marking devices.
So we can have a lot of information at the marking, and we can even track the parts when it's installed. We can put the information when it's even produced.
Yes.
So like a really modern product.
Exactly, yes. And now we show the laser marking, but we can have also inkjet marking or labeling device.
And now again, the direct flow from shearing process to the bending process.
And once again, gray door is on its way to the bending process. Here we see nicely the Prima logo, which we made with the offset wheeling.
And also the negative offset wheeling around the door handle, looking really good there.
So that's about it. I think we can go back to Antti.
Yes, it's really interesting to see when this magic happens really for the components, and all these formings and markings appear to the components. Now we have here this second door here, and we have components here. So Antti, can you explain a little bit what we actually were made in?
Yes, of course. Now we can take a closer look of this door leaf that we have here unassembled. And I want to point out, especially for you, the offset forming in here and the quality of it. So even though we are here in the corner with quite tight corners and turnings, there's not any scratches or markings or anything from the tools. So it's a really high quality door, and you can send that one directly for the customer, even though it's a pre-painted material. Same way in here in lower area where we have this offset area around the handle, same thing, really good finishing quality on here. And the difference between these offset areas is that this Prima Power logo is made outwards and this door handle is done inwards. So it doesn't matter which way you are doing the offset areas or rib wheels. We can do both of them. One thing I want to point out is also this thread that we have in here. So you can turn the screw just by fingers that well that thread is made, so it eases up the assembly a lot. And here in the bottom we have the rib wheels that we added here to bring the design for the door, but also stiffness for the door. Then I want to show you the frame that we made. So in here we have an extra groove made. So over there we can install the gasket for the door. So it eases up also the assembly of this door, and we can just slip in the gasket on that groove. Then we added on this frame markings. So here we have an order number, so we can follow up this part that is going for the right customer. Then we have the QR code from where we can read all the information related to this part. And then we have also some text saying that this is a upper frame, so the welder knows where to put this part when it's doing next step, which is the welding for this frame.
One question about this really nice groove. Is there some trick how to do that?
Yeah, so you may not see it from the cameras, but it's only like a 1 millimeter gap, and for that we have done on a punching machine so-called bend wheels. So we have done 3 small engravings next to each other over here for the bending line, and it helps us to have this really tight and narrow bending.
And it looks to me that this is, I think it's impossible to make this kind of and this quality with the press brake. So
yes,
panel bender is needed for that.
Yeah, and over here especially it's about the automation. When we have the punching machine connected to the bending machine, we can do the engraving on a punching machine and then finish up the bending on a panel bender.
Mm-hmm. Just came to my mind one question. For example, this type of doors and combining now the information I already have learned today is that, for example, if I want to have a mailbox here, can that be like one of the parameter for the automatic programming?
Yeah, you can put the parametrical things for like it's there or it's not, like the mailbox, or you can put parametric things like the height, width of the part and so on. You can also add there 2 hinges, or that can be parametric. You can have 3 ones if you wish. Mm-hmm. All and those things can be selected on order file.
Left-handed, right-handed, different colors.
Yeah, whatever you have in mind.
This is really good. So thanks, Antti. As we noticed that now the design can be variable, so several different designs can be done, but also the customers can have different focus areas. For example, the frames or doors, and also they can do some, let's say, subcontracting, for example, using the same line. And this is something that, of course, is interesting topic, because we can offer so-called standard lines, and our automation is modular, so we can increase and grow with the customer demand. So meaning that when the production volumes are growing, so we can add automation modules, and also, of course, then we can customize the lines and add some industrial robot, etc. So Lauri will show us now a little bit about this kind of dedicated lines and customization, or so, Lauri.
Yes, Antti, as you mentioned, all the automation what we have is fully modular, so you can add it straight away or afterwards. So you can grow your standalone machines to the whole production line. Or you can add the capacity, example, adding another bending unit, or have some robot solution for material handling or the part handling, and also for raw material, example, storages. But I would like to tell a little bit more about this.
Absolutely, go ahead.
Yeah, let's start the presentation. Automation for door frame manufacturing. Today we saw how we produce 2 different types of doors at our PSPP line. Here is picture about PSPP's direct configuration. It's ideal solution when there is no buffering needed and it provides small footprint. In this presentation, I will show how we can add automation and maximize our production capacity. PSPP line can be equipped with picking stacking robot. It brings the flexibility to your door and frame production. So with the picking stacking robot, you can pick and stack your doors and frames to the wagons or the pallets. We have also buffering unit in our robot area that balance the flow between these machines. So we will maximize our production. Parts can be also added from external sources to our production line and bend those. Today, when we produced this complex door, we produced gray door and the white door. The secret for that is fast loading storage. We can have immediate material changes thanks to the sheet-by-sheet loading solution, fast loading storage. It also provides long unmanned production. PSPP lines can be equipped with the coil line. So it brings the long unmanned production. It gives material cost savings, normally around 60 to 40 euros per ton. And it provides optimal sheet length used for nesting. When there is need for more bending capacity, we can add a second bending unit to our production line. So according to the dimensions, parts can be bended with either production line or robot support. We can have also dedicated benders for the frames and the doors. So this solution gives much more production capacity to your production. And we have here in this solution our picking stacking robot, so we can have much more flexibility to the production. Parts can be also added from the external sources for either of these benders. This is optimal solution for door frame manufacturing. Of course, production volumes can increase quite a lot. Here we can see the picture with two PSPP lines with night range storage. Night range storage can serve multi-van production line, and it serves both of these production lines, and we can have a lot of different materials available fast. In this line we have a dedicated line for doors and the frames to maximize our production capacity. Night range storage can serve multiple production lines. As we can see here at the picture, optimal solution for doors and the frames. Here we can see at the left corner there is a coil line connected to our PSPP line, but there is also fast loading storage connected to the night train and our PSPP line, so we can have really fast material changes straight from the night train. Here at the right side of the picture we can see roboticized bending cell, so we can take bended parts straight from the night train and bend with the robot. This is really for the high capacity solution.
Oh, Lauri, it really looks that we can go step by step and grow these lines, and also integrate the industrial robots and make it exactly like the production needs requires. Very good, very good. So, we have going through now the programming and order management and production, design, quality, all these aspects. And now we are getting closer to the end of this short event. I hope you have been enjoyed. Before we stop, of course, there was a possibility for you to send the questions, and have been very active. So thank you all of those questions. Okay, there is some questions, so we will going to answer some of them already. So Johanna, you have some questions there. So thanks. So we can go through these ones. Okay, interesting. So there is a very good questions. I don't even know my answer myself. So Pasi, since we were talking about the ERP systems that we can make the connection, the question is that how we can connect, or what technology we are using when we connect. with the customer ERP?
Okay, we have two ways to connect that to ERP. That there is file communication, which is quite common. There is CSV and XML formats, and then we have a REST interface, which is new one for quite common also in new ERP systems. Both are supported.
Okay, good, perfect, thanks. Then there is a second question, is that the Lauri, you were showing several different types of production lines. The question is that what is the most common for door, especially for the door manufacturing?
This is a really good question. The most common production line for the door at frame manufacturing is the PSPP direct line, and nowadays it's usually equipped with the seat-by-seat loading solution, so fast loading storage for single kit production.
Okay, thanks, Lauri. Then question is that if and when there is a need to invest this type of line, so that what is the lead time to get this kind of production startup for this new type of automatic line if a customer placed the order? And then, okay, it depends, of course, our load in the factory, but in general, it goes so that if and when we get the order, then there is like 3 to 4 weeks production time here in the factory. And then when we do the installation, startup, training, and production testing takes 1 to 2 months, depending on the configuration. So approximately the day when the order is made, and approximately 6 month time, half year, and then the production can really start. Then the question, Marko, about the panel benders. The question is that this angle correction, and so that was that really meaning that if I do like a prototype door, that I can get immediately the right correct angle for the bendings?
Yes, this is absolutely correct. There's really no prototyping, like you get perfect quality right first time. And when we have, for example, new material, we can add these values to database for future purposes. So
okay, so this parametric goes to automatically the database.
Yeah, and it's actually inbuilt quality control system automatically.
Okay, this is very good for the short series and production run and improve the quality. Then next question is that the customer is asking here that they are producing now the doors like a traditional way. They have the standalone punching machine and the press brake, so that they want to now to make the step forward and invest automation, so that can we help them to make the design, make some small design changes if needed, and also to plan the line configuration as per the customer needs. So Antti, can you answer that one?
Yeah, I can take this one. Of course, these cases, as these are system cases, this always requires some feasibility studies, and we are happy to help with the customers how their products would suit our machines, which are the right correct machines for their products, and what kind of options do we need there. And same time, we can also think about the future. So if they start with the punching and shearing machine, but they have an idea to get a bending machine in the future, we can already take that into consideration in the first place.
Very good, very good. Okay, time is running, and there is, of course, a lot of questions answered already during this event. And of course, anytime, please, we are here just for you, and you can send all the questions to us. And also, please contact your local Prima Power sales representative, so we can help you to evaluate and check your components, parts, and then check the needed line. Now this event dedicated for the doors and frames. Obviously, there is a lot of common in all other big panels production, like elevator doors and as well. So anyway, of course, please send your comment, contact us. So we are more than happy to make the dedicated demonstration for you throughout this virtual systems. So from my side, thank you. That was very interesting, and thank you for being active and following this event and spending your time with us. So from my behalf, thank you and see you next time.
Thank you.
Thank you. Bye-bye.
Thank you for visiting us. See you next time. Bye-bye.
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 Bye.
Auf Wiedersehen. Hey, hey.
Hey, hey.